This video covers EOC Review 1, Reporting Category 1, Day 1. So the notes packet, if you are in class or if you picked it up, you'll see that they are yellow. If you've printed it off the website, then they will be white, but this is what it looks like for the most part. So if we start up in the top left, we're talking about polynomials. There are two different things that happen with polynomials. The first thing that can happen is that you add or subtract them. You will see that if you have minus signs, not negative signs, but minus signs and plus signs with no parentheses. When you are asked to add or subtract polynomials, you're basically asked to simplify the problems. When you simplify, it is adding or subtracting the coefficient, so the number in front of the like terms, and you do nothing to the exponents. So on this problem here, we have 3x squared minus 2y plus xy minus 2x squared minus 6y. Now, the combining like terms part has already been done for us. What this person did is underlined their x squareds, they double underlined their y's, and they left the xy's alone. Now again, when you combine like terms, you leave what follows the x squared and the x squared, you leave the x squared alone, and only combine the front pieces. So with my x squareds, I have 3 minus 2 for a total of 1. Now remember, we don't have to put 1, we don't have to show 1. The xy is the next thing that comes alphabetically, so plus xy, there are no other like terms to change it, so I simply rewrite it. With my y's, I have minus 2 and minus 6. My y stays the same, and when I combine like terms, negative 2 minus 6 is a negative 8. From this point on, I do not have any other like terms that I can combine, so this is my answer. The other thing you might be asked to do to polynomials is multiply them. You will know that you should multiply when you are given parentheses and you basically distribute whatever is in front to all of the pieces that follow. When you distribute, you multiply the coefficients, so big numbers in front get multiplied. They act like normal. You add the exponents of the like bases. So if you have letters that are the same, you add the exponents. So 3x was multiplied by 5x squared, 3x was multiplied by negative 2, and 3x was multiplied by negative 4, and all three of those are broken up here, here, and here. From there, you multiply big numbers like normal. 3 times 5 is 15. X times x squared is x cubed. So 15x cubed is what this simplifies to. Negative 2 times 3 is negative 6. And x times x is x squared. Negative 4 times 3 is negative 12. And then the x just follows. So remember, you add your exponents only when you multiply. Over here on the left side, when we added or subtracted, we did not change the exponents. When you multiply, you change the exponents. If you would like to pause the video at this time to try this problem, you may pause now, and then I'm going to go through the explanation when you press play. So don't forget about this negative. We see parentheses, so we need to distribute 1/2 times 8a and 1/2 times 6b. We also need to distribute negative 3b times 6a and negative 3b times 2. Remember that you multiply the big numbers. So 1/2 times 8, or half of 8, is 4, and the a just follows because there's nothing to change it. 1/2 times 6b Half of 6 is 3, and then a b. In blue, negative 3 times 6 is negative 18. A times b is just a times b. There are no like terms that I can combine, so I just rewrite them. And negative 3b times 2 is negative 6b. From here, I combine like terms, so I have a 4a and nothing else to change it. I have 3b minus 6b and negative 18ab. So in order, ab comes before the b, so 4a minus 18ab. And then my b's, I have 3 over here and negative 6 over here. So 3 minus 6 is negative 3, and b stays the same because you do not change your exponents when you are adding or subtracting. Now, on the second part, we're talking about the laws of exponents. Exponents tell us how many times to multiply a number or expression times itself. So 2 to the 5th is really 2 times itself 5 times. To figure out what this translates to, we use the up arrow button on the calculator, and we type it in exactly like we see it. So they want me to simplify 2 raised to the 5th. So I'm going to click 2, the up arrow to get into the exponent, and the 5th. Keep in mind, anything that has a small exponent, whether there's lots of small exponents or one set of small exponents, all need to be written like this. If there was something else I needed to type after this, I would hit the right arrow to get out of it and keep typing. However, this is all I'm looking for. So my answer for 2 to the 5th, it equals 32. Underneath, we have square roots. Now, we have not spent a unit on square roots. We're going to do that after the EOC because we can teach you what you need to know for the EOC. We can teach that to you on the calculator and then really teach you what you need for geometry after the EOC. So what we're going to do is use the calculator to estimate these types of problems. To plug it into the calculator, we're going to follow these steps, and we're just going to type it in exactly like we see it. So I have a negative 3 in front, so I click negative 3 on my calculator. Be careful not to use a subtraction sign. To get the square root is listed right here in blue. So to get the blue button, we click second and then square root. Under the square root on my paper, I have 2/16, so I type all of that in like I see it. Again, if you need to type something not in the square root, you click the right button, and then you can keep typing. However, they just want to know what it equals. So we're just going to get it into decimal form. So this is like negative 44.1. On any assignments or any of these EOC things that we're doing, you're probably going to have something like this, and ABCD answer choices with other square roots. What you need to do is plug this into the calculator and simplify, and then take your ABCD answer choices and see which one of them give you this number. If it's a whole number that doesn't match negative 44.1, then you could mark that out. If it's a square root, type those square roots into the calculator as well and see which one has the same decimal. So you might want to write here, compare decimals, because that's the easiest way to solve those problems. Okay. So we're continuing the law of exponents back here. So there are further rules with exponents. So if it's not something that you can easily put into the calculator, then you have to follow these rules. Remember that we take it number by number, letter by letter. So do your numbers first, then take it one letter at a time. My advice to you on these problems, especially if you have multiple choice answers, is to do your numbers and then check your answers and see if there's anything you can mark out. Then do a letter, see if there's anything you can mark out, because sometimes you don't have to do the whole full problem, you just have to do certain pieces to get the answer. So let's review all 4 of our main exponent rules. The first one is the product of powers. When you have a base with an exponent times a base with an exponent, you're really going to take the base and add the exponents, and this is what's shown on your formula chart. So for example, if we have 8x to the 4th y to the 6th times 3x 3y 1, invisible 1, in parentheses. Parentheses tells us to multiply, so we take it number by number, letter by letter. So 8 times 3 are both big numbers, so the big numbers get multiplied, just like normal, 8 times 3. Then letter by letter, I have an x to the 4th here and an x to the 3rd here, so I rewrite x to the 4th times x to the 3rd. With my y's, I have y to the 6th times y, so y to the 6th times y. And this is how it is rewritten, number by number, letters and letters. From here, big numbers are normal, so 8 times 3 is 24, and that's just as though we were back in 3rd grade learning how to multiply again. With the little numbers, remember the formula chart reminds us that we add, so x to the 4 times x to the 3 is really x to the 4 plus 3. 4 plus 3 is 7. Y to the 6 times y to the 1, again, they are multiplied, so we add. 6 plus 1 is 7. The next rule is the quotient of powers, where we have a to the m over a to the n, where you will really subtract your exponents. You would have a to the m minus n. So anytime we see a letter on top and a letter on bottom, we subtract our exponents. So take it one step at a time. 12 divided by 6 is rewritten over here so they line up. A squared over a to the 5th is rewritten so they line up. Your b's line up, and you have a c on the bottom but no other c up here. The first thing I would do if this was a multiple choice answer is check to make sure my answer choices have that one piece that is not moving. If any of them do not have c to the 4 in the bottom part of your fraction, I would X out those answers. I would then look at my numbers. So 12 divided by 6, you put it into the calculator exactly like you see it, 12 on top, divided by 6. If you need to, remember math inner will turn things back into a fraction. But this one has a 2, and just a 2, so no other piece to it, and therefore the 2 goes on top. I would then check my A, B, C, D answer choices to see if any of them do not have a 2 on top. And depending on what else you've checked, that might tell you what your answer is. But if it doesn't, we move on to the A's. So with the A's, I have 5 on the bottom and 2 on the top. Because 5 is bigger than 2, in my calculator, I will take the bottom and subtract the top to see what my new exponent would be. Because I started bigger in the bottom, my answer will end up in the bottom. So a to the 5th minus 2 is a to the 3, and it stays on the bottom because that's where I started with more exponents. With my b's, I do something similar. I have 8 on top, 2 on the bottom, so top minus bottom because I have more on the top. And there's a total of 6, and they will go up on the top because that's where my bigger ones started. If you have a power to a power, there are 2 options to complete this problem. The first option is to stamp it out. So you write what's in parentheses this many times, which is listed here. 3c squared times 3c squared times 3c squared. Then you treat it like the first example where you do 3 times 3 times 3, so bring your numbers out in front. And then your letters in the back. So take it number by number, letter by letter, c squared, c squared, c squared. And then 3 times 3 times 3 simplifies to 27. C to the 2 plus 2 plus 2 is 6. If you like this option, then stick with that option. With these 2 options, you need to choose one option that you know you can remember and roll with it. And do it well and get them right every time. Do not try to do both options. At this point, you need to pick one and stick with it. Even if it looks like more work that you're writing, if you can get them right, then do that. The other option is to use your rule for a power to a power. The rule is shown here where we have a to the m times n. They're right next to each other, and so we multiply. When you do it like that, everything inside of your parentheses gets a cubed. So it's like distributing backwards. 3 gets a cubed and c squared gets a cubed. If you do it that way, then it's a little bit less writing. All you have to do is take 3 to the third, put it in your calculator like this, 3 raised to the third, and you get 27. And then multiply your exponents. 2 times 3 is 6, so it's 27c to the 6th. You get the answer either way, so pick a way that you like and stick with it. The last important rule is negative exponents. If you have a raised to the negative n, your formula chart tells you to make it positive. So wherever your exponent is negative, that means it doesn't like being there, so you need to move the exponent and change the sign. So with this problem, we have one letter or one number, one p, one x, and one m. So there's nothing I can combine. My m has a negative 6. So I would move it to the bottom because it is negative, because it doesn't like being where it is, so we move it and make it happy. At this point, I'm going to continue my explanation of these examples, so if you would like to try them and then check your answers, please pause the video here. So for this example, we have 3x to the 1/2 times 4x to the 1/3. Because these are multiplied, I take it one piece at a time. With big numbers, you multiply them just like their normal third grade things that you've learned. So 3 times 4 is 12. Don't be afraid to use your calculator to check that, just to make sure you don't trip up on something like that. With your exponents, because they are multiplied, we really add. So in my calculator, I'll do alpha y equals 1/2. Plus, because they're not right up next to each other, so even though it shows multiplication, I'm smarter than that, and I check my formula chart, and it reminds me that I need to add. And I get that my exponent is really 5/6. If you struggle with fractions or you cannot do them in your head, that is not a bad thing. That's not something you have to be ashamed of. If you don't use your calculator to get better with that, that is something to be ashamed of. So do not be afraid to plug things into your calculator and double check your work, double check your thoughts. Do not miss something small and silly because you could have checked in the calculator. With this problem, we are dividing, so we're going to take it number by number, letter by letter. So I'm breaking this up so I can see it a little bit better. So for this problem, 5 divided by 10, I plug into my calculator, 5 divided by 10, and remember you can do alpha y equals 2. I get a decimal, so math inner, this is the fraction, 1/2. With my exponents, for x's, I have 3 on top and negative 2 on the bottom. The top is bigger than the bottom, so I will do top minus bottom. Be very careful here because it is 3 minus negative 2, and we get 5. That stays on the top because I had more exponents on the top to begin with. For my y's, I have a negative 2 and nothing else. My y's do not like being on the top, so I change my exponent by moving it to the bottom. My y's are unhappy on the top, but when you move it to the bottom, they become happy, so you get rid of that negative. With my z's, I have an invisible 1 on top and 2 on the bottom, so I do bottom minus top to get 1. And they stay on the bottom because that's where you have more exponents to start with. Keep in mind, those 1s are invisible ones, so the answer might be listed like this, and these mean the same thing, We just don't have the 1 and don't have the 1. So if you write the ones, don't let the lack of ones confuse you. Please, please, please know that those are the same thing. For this example, there's a lot involved with it, so we have to take it piece by piece. The first thing I need to do is distribute my parentheses, or to get rid of them. So I have 4xy to the negative 3, and this is all being squared. I'm going to do the distribute the squared route. So this would be 4 squared x squared y to the negative 3 squared. So everything that was already listed in the parentheses is getting a squared. In my calculator, 4 squared is 16, x squared is just x squared, and then times y to the negative 6 because we multiply these because they're right next to each other. I've done nothing else to the rest of the problem, so I'm rewriting the pieces that I did not use so far. I'm then going to attack the top because the top has multiplication, which I need to tackle before I divide. So on the top, number by number, 16 times negative 2 is negative 32. And then look at your letters. X squared times x cubed, we add to get x to the 5th. Y to the negative 6 plus 2 is negative 4. And I have not done anything with the bottom yet. Now that I've taken care of my multiplication on the top, I'm ready to divide. So number by number, letter by letter, in my calculator, negative 32 divided by 6 is negative 5.3, repeating. So I click Math, Enter to find out that it's really the fraction negative 16 over 3. With my x's, I have 5 on top, negative 4 on bottom. 5 is bigger than negative 4. So I will do top minus bottom, so 5 minus negative 4, and get 9. And that goes on the top because I started with more exponents on the top. With my y's, I have 6 on the bottom, negative 4 on the top, so 6 is bigger than negative 4. So I will do bottom minus top and be very careful with those negatives and get a total of 10, and they stay on the bottom because I had bigger exponents on the bottom to start with. When we multiply polynomials, a polynomial is a type of expression with 2 or more terms that are separated by plus and minus signs. To multiply polynomials, we use the box method. Remember to combine like terms when you are finished. So this example has already been done for us. They set it up with 3x plus 1 times 2x minus 5. And this is where we use the boxes like they do in biology. And you do top times side to fill this in, top times side to fill this in, top times side, top times side. And then we combine like terms on the diagonal. So negative 15x plus 2 is a total of negative 13x's. So I would rewrite that I have that I would have 6x squareds, negative 13x's in total, and then a minus 5. If you would like to try the one on the left, you can pause here. Otherwise, I'm going to do my explanation. So I would start my box off and do 2x plus 3 and x minus 5. To fill in the box, I do top times side. So 2x times x is 2x squared. 3 times x is 3x. 2x times negative 5 is negative 10. 3 times negative 5 is negative 15. I combine my like terms on the diagonal as long as I follow my setup. Negative 10x plus 3x is negative 7x. So in total, I have 2x squared minus 7x minus 15. When we factor polynomials, factoring is the opposite of multiplication, and you need to make sure you put a star next to these steps because anything you do with factoring is going to follow these steps. So if you get stuck on factoring, you need to pull this out and look at these steps and redo them. This example has already been done for us, so I'm just going to talk you through it and then we'll practice some. So for this first example, you would look for a GCF first. 2x squared, 6x, and negative 108 all share a 2, so my GCF is a 2. Whatever they share, you divide it out of all of the terms, put what they share in front, and put what you've divided in parentheses. So when I take out a 2, 2 divided by 2 is an invisible 1, 6 divided by 2 is 3, 108 divided by 2 is 54, and you leave your signs the same and leave your x's the same because I did not have an x that they shared. From here, your first and last terms start your box, and you start on the inside and work your way out because we're working backwards from the last problem. My sum is always the middle number that does not go in my box, so 3x. The product is your last number times your first, so the two things that you did put in your box, so negative 54x squared. From here, we hop to using the calculator. In y equals, we put the product number, negative 54, divided by x. We look at the table, and we look for two numbers that add across to my sum of 3. Those numbers in this case are negative 6 and positive 9. Those numbers are written in the missing pieces of my box, and then I factor out my GCF by working vertically and then horizontally. My answer is my GCF and then the two terms that I have on the outside. I apologize. So the two terms that I have on the outside all make up my answer. So at this time on the back, we're going to do two examples. If you would like to pause the video and practice them and then press play, my explanation will follow. So for this first example, we have 4x cubed minus 36x squared plus 80x. So these all share a 4 as well as an x. So I will divide out a 4 and an x from every piece. When I divide by 4, 4 divided by 4 cancels. X to the 3 minus 1 is 2. Negative 36 divided by 4 is negative 9. X squared divided by x is x. 80 divided by 4 is 20. And my x's cancel. Remember that I use my parentheses now to start my box. So my box has an x squared and a plus 20. I multiply those for my product. My sum is what is not listed in my product. And in y1, I put my product number divided by x. So in my calculator, I'm putting 20 divided by x. I put the product and search for the sum. Now my sum is a negative 9, and so far I've noticed none of these have negatives. So I'm going to scroll up to the negatives, and I'm looking for two numbers that add across to negative 9. So this would give me negative 12. Remember, we skip things with decimals or fractions. We only look at whole numbers. Negative 4 and negative 5 would give me a negative 9. So those are going to be my two factors that fill in my box. From here, I factor out my GCF going up first. So x squared and negative 5x only share an x. They do not share any numbers. Negative 4x and 20 share a negative 4. Whatever the sign is for the terms you got out of the calculator is the sign that will go here. X squared and negative 4x share an x, and negative 5x and 20 share a negative 5. My full answer is my GCF, my term, and my other term. If there are questions that ask you which of these is a factor, they're probably looking for one of these three pieces, but you have to work the problem out completely to know what pieces are in your problem. For this other example, we have 12x squared plus 7x minus 10. If you want to practice this one, press pause now. Practice it because my explanation follows. My GCF, 12x squared, 7x, and negative 10 do not share anything. They do not all have the same letter, and none of the numbers that they share are the same. This means I can go straight to my box, which has the 12x squared and the negative 10. I multiply those for my product of negative 120x squared, and that is what I will put into my calculator. My sum is 7x. So in my calculator, I put negative 120, and I am searching for two numbers that will add up to a positive 7. I click second graph, and I'm looking only at whole numbers. I'm trying to add to a positive 7. None of these will add. That would give me negative 14. This would give me a negative 7, but I need a positive, so let me go see if the other way, a positive 15 and a negative 8. Remember, if you're not sure, positive 15 plus negative 8, and that would give me a positive 7. So positive 15 and a negative 8 are the pieces that go in my box. From here, I factor out my GCFs, going up and up, and then side and side. So 12 and negative 8 share a 4, x squared and x share an x. 15x and negative 10 share a 5, and it is positive because this term is positive. 12x squared and 15x share a 3 as well as an x, and negative 8x minus 10 share a negative 2. It is negative because the term I got out of the calculator was negative. So my full answer is going to be 4x plus 5, 3x minus 2. Remember, a quick check that you can do is to make sure this times this equals this, and this times this equals this. You don't have to go through the whole thing, but check those two pieces, because if those two pieces are wrong, you're going to know that you did something wrong. A little bit of vocabulary review for you, and I'm going to go a little bit faster on this. An algebraic expression has no equal sign. Something like 5x minus 3 would be an expression. Both of these are terms. Your variable is your letter. Coefficient is the number in front, and constant is the number that does not have a variable or a letter. An algebraic equation has an equal sign, so like x minus y equals 2 is an equation. Expression is just you express yourself, but there's no equals in there. An expression is a phrase that contains ordinary numbers, variables, and operators, so 2x plus 7, 5x minus 3. The degree of an equation is the highest exponent that you see. So the degree is the largest exponent of that variable, the largest exponent of the variable. So here, x plus 7 has a degree of an invisible 1. Here, my biggest exponent is a 2, so it has a degree of 2. Factors are numbers or expressions that can multiply together to get another number or expression. So factors can be listed just as numbers because 2 and 3 are both factors of 6, where 6 is the product of two things that have been multiplied. Or factor can also mean things, expressions in parentheses, where this factor and this factor can multiply to get this product as well.